Hello, everyone. Once again, welcome to my stream. In this series of streams, I am working on recreating a simple game called Suika Game, where you drop fruit on top of each other, um, and if it's the same fruit, they combine to form a bigger fruit. And once you get to a water, it disappears to clear out space for you to drop more fruit on top of each other. So let me open up my files and start the server and then show where I'm at. So the two JavaScript files I'm mainly working with are these two game.js and modules.js. I might end up refactoring them or combining them later on once I get the entire thing working. Um, but yeah, so this is what I got so far. I have the container box and this is where we'll be able to drop fruit in. And it's translucent, so you can see a watermelon. Got a floating box. Can also add more fruit in currently by using this form, specifying the type of fruit and then the coordinates x, y, and z. So let's see. What we worked on in the previous stream was making this box container. So we're done with that. Today, I think I'm gonna work on this object interactions by the user mouse. So this would be, wherever I click, I want a fruit to drop down from where I'm clicking from the top. So uh, right now for this stream, we'll start off just by adding a fruit wherever I click at the point that I'm clicking at. So let's see, gravity, object interactions with each other. Yeah, so this will be what I do right now. And then we'll see. If it takes a long time, then that'll be the entire stream. If I get done with that really fast, then we'll move on to maybe the gravity. So that gravity will be when I click, the fruit will drop down from the top and hit the bottom. So with that said, let's start Googling. Um, okay. Cool. So it seems like this will get me the coordinates of where I'm clicking. Then I will, yeah, let's just add it, and then we'll look at what to do past that. Okay. So the main function, it grabs the canvas, and then yeah, so I have added another function called add fruit. Let me see where that is. So okay. Canvas, const canvas, GL canvas. Okay, so the element is called canvas. All right. So let's add canvas dot add event listen. So I'm wondering if it should be a mouse down or a mouse up, because in case if the user is dragging around the mouse before letting up. And then I also want to make it the touch as well. So I don't need this. Or, well, maybe I do. Yeah, because Canvas isn't globally available. So I need to pass it in. Alright, let's see. Get cursor position gives me the cursor positions. Hmm. Hmm. But add fruit. Add fruit. So I want to work it in. Um. Fruit to canvas. Right. So the Y should not matter that much. And then, yeah, and then add this object. So I'm gonna just do X, Y, and then for the Z, that's how far it's coming out of the screen. I want to see what I'm doing for the box. So minus 6.0. So that's what I want to do, minus 6.0. Hmm. So one thing to note is that this might be a lot bigger than this, which will make it go like way off the screen. So I wanna um, also log the values to see what kind of values I'm getting. All right. Right. And then also, so I'm gonna just for the fruit, I wanna just yeah, I wanna just have a generate a random fruit. So let's see. A helper method. So let's check what let's look up the random number generator. All right. Get random int times max. So math.floor. So let's see. Uh yeah. Um so for the random fruits, I want to be able to drop grapes, cherries, limes, lemons, and up to honeydew. So that's 1, 2, 3, 4, 5. So 5. And then fruit sizes. Fruit sizes is the name of the fruit sizes. 5. Sizes. So it's like object.keys, I believe. Yep. Object.keys. That'll get me the keys. And then pull out a random one of them from 0 to 5. Yeah, that should do. So that'll be the name of the fruit. And then, yeah, and then just fruit sizes, fruit. Get the value of the fruit size. So maybe I don't need the parse floats because these will already be numbers. Ah, all right, let's check it out. Open up the developer tools and then start clicking away. Okay. So yeah, as I suspected, these numbers are way, really big. Way out of bounds for this window. Because so keep in mind, this is like only a dimension of like 2 or 3. So let's yeah, so we need to scale this down a lot. scale down the numbers. Client X, client Y. Well, let's do one more test. So let's see what this is up here. Okay, so this is 2, 0. 2 is X. Okay, so it's up to, yeah, so it's 600 by 800. That's the max. Um 600 by 800. And then let me check what my so this box is spanning nearly the height of the box, and from what I remembered, it's like single digits. So let's see here. Position, box position actually. Yeah, so 2 is actually the max. And actually, I want to make this a little shorter from, so not like all the way, not reaching all the way to the top. So then we have some space for the fruit to be displayed when it drops down. So, let's see. So that's x, y. So that would be the y coordinate. Uh, Y coordinate. Let's just try making all the negative 2's -1. For the y's. So if it's a -2, then I make it a -1. But if it's a 2, then I'll leave it as that. All right, let's have a look. Okay, so that made the box. So I did it the wrong way. Okay, so let's redo that. So for if it's so it's if it's -1, now I need to revert it back to -2. And then conversely, if it's 2, now make it 1. 2, 1, negative, or yeah, -1, -2, 2, 1, 2. All right, 2, 1, -1, -2, -2, -2, 2, 1. All right, let's try it now. All right, yeah, more like it. Yeah, so this is the container that we're going to be dropping food into. Now I want to look at the draw scene. I'm trying to find where I have. Okay, so yeah, canvas client with client height. Client with client height. Field of view is 45 times pi 3. 45 times 3, that's 180. something. No. 3.14 times 4. 120 something. Maybe 130 something. Z far. Z near. Z far. So it's something to do with the perspective. Hmm. So what I'm looking to do is to translate these coordinates. Yeah, let me draw it out. So we have two coordinates. One where zero, and then this let's check. 600, 800. 600, 800. And then yeah, the other fill in. And then in WebGL, what I'm seeing is let's see, is more like the center is in the middle, and then this is what is this? So the Y. Yeah, let me go back to the box position. So Y -2. Okay, so it seems like it's maybe 2 -2, and then this is uh yeah 2. So I need to convert this word to that word system. So I'm gonna. So yeah. So thinking how to do that. Yeah. So let's see. Uh, let's try some parametric algebra if I still remember how to do that. Okay. So when x is 0, y is 0, or yeah. Let's see. A B Y C. This is A. This is X. So we'll ignore the 0, 0 for now. 600. No, 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 no. Doing it wrong. Probably a ax plus by equals ax plus by. So this is all right. Solving for a and b. Maybe possibly plus a c. All right. And then this. All right. So let's list everything out. Okay. Or maybe we can do it this way. A1 minus A2 plus BY1 plus BY2. So now let's plug everything in. So 0, 0 would be negative AX2 minus BY2 equals C. Or, yeah, nah. I don't have unlimited space. I need to conserve. So let's just do negative A, negative 2 minus B2 equals C. So that'd be 2A minus 2B equals C. 2A minus 2B equals C. Now let's plug in the 600. 600 A minus 2A plus 800B minus or plus 2B equals C. Simplifies down to 598A plus 802B equals C. And then one more. Let's do 600. 600A minus 2A and then plus 0 times B minus 2B equals C. Okay, so we have 3 unknowns and 3 equations. So let's start solving. Gonna clear out all the intermediate statements. 598a minus 2b equals c. So let's see. So 598a plus 802b equals 598a minus 2b. So 802b equals 2b. Well, that doesn't make sense. I think I've lost my math skills. It's been more than maybe like almost 20 years, 15 years at least. Yeah, okay. Yeah. So then let's just do it the logic. All right. So that's so I would shift it or so x so multiply by some scale. So x should be so x2 should be I multiply this x1 by something and then possibly add on a offset, and the same thing goes for y. Yeah, these a's and b's may not be the same. So let's just try negative 2 equals bx. Yeah, that was fairly simple. Yeah, negative 2 equals bx. Let's think about y. y2. 2 equals by. All right, well, and then 2 equals 600. 600a plus or minus 2. 4 equals 600a. A equals 2 over 300. And then we'll use the other two coordinates to double check. Next, negative 2 equals 800 a x x oh no ay 800 ay plus 2. So negative 4 equals 800 ay. Ay is negative 1 over 200. All right, let's plug them in. X2 equals ax 2 over 300 x1 plus or minus minus 2. y2 equals 1 over 200, y1 is 2. All right, using, so we've tried, so we use this coordinate, and this coordinate, and this coordinate, and this coordinate to solve the equation. So let's use this one to verify if it's correct or not. So does 2 equal 2 over 300? Does 2 equal 2 over 300 times 600? And then minus 2. So that's 2. 2 times 2 is 4. 4 minus 2 is 2. So that checks out. Y, okay. Does 2 equal 1 over 200 times y1, which is 0, plus 2? And yes, that does. This is 0, and 2 equals 2. So this coordinate checks out. Final coordinate, this one, negative 2 equals 2 over 300, or well, this is 0 minus 2. Yes, that's right. And then final one, minus 2 equals 1 over 200 times 800 plus 2. So negative 4 equals, plus 2 minus 2. So this is showing 4 equals negative 4. That can't be right. Wait. Did I? Negative 2. Wait, plus 2, plus 2, negative 2, negative 4, 800. Yeah. Let's double check. So with going all the way back to using these two. So 0, or y2 is negative 2 or 2, yeah, 2 should be y, ay, yeah, ay. All right, let's try the, so by checks out. Try this, y, ay, y2. So negative 2 equals 800a plus 2 minus 2. Okay. Yeah, negative should be a negative. Negative 1 over 200. AY is negative 1 over 200. Yeah, I missed that. Negative 1 over 200. Since this is 0, that cancels out. Yeah, okay. Yeah, yes. Okay, well, glad we figured that out. So this is the equations we need. Now we'll do it. Init box. Okay, yeah. So going back. Well, I'm glad I didn't lose all my math, even though it's rusty. Definitely rusty. Yeah, so const x. So offset. So offset. We have x1. We need to convert it to x2. So x1, so 2.0 divided by 300.0 times x. Avoid any confusion. And then minus that gives us x. This would be y divided by negative 200.0 plus 2.0. Okay, try it. Cool. Yeah, pretty awesome. Yeah, awesome. So that worked out. It's not perfect, you know. You can see that it's not perfect, but it's good enough. So see, when I press down, if I don't lift up, it already has the object. So I'm gonna change it to, instead of mouse down, I'm gonna do mouse up. And also, yeah. So first that change, then we'll come back to this. Mouse up. Um, okay, so now instead of adding the fruit wherever I'm clicking, I want it to always be from the top. So that would be Y. So Y would be 0. Let's do, but instead of 0, which would cut off half the fruit because it would clip at the top. Let's do 0.1 or 0.2. How about that? Now let's try. Oh, okay. My bad. Yeah, but you can see it's yeah. So right. It's more like 1.8. So, because this axis, this is the 0. So I need to offset it. by almost the entire amount. Yeah, there we go. How about that? Eh, 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 eh. Maybe even more. 1.9. Actually, how about just 2? Let's just try 2. Yeah, okay. It's not, that's pretty good, I'd say. I'd say that's pretty good. Yeah, and you can see it's all different shapes and sizes. And now, like, I have my mouth but it's only and I can, and it's only when I release that you get the fruit popping up. So yeah, that's great. Got this working. Let's commit the code. Gonna get rid of these debugging statements now that we don't need them anymore. Yeah, and small math, little bit of math. My parents would be ashamed of me. Object interactions by the user mouse. Got that. Next, now it's time to do the gravity stuff. Coming up, coming up shortly. Hard stuff. The hard stuff. But first, let's commit. HG stat 1221. Um, all right, great. Glad that that is done with. So now we're pretty much done with the WebGL portion of this code. Now moving on to the physics. So for the physics part, it's really just all about math calculations, calculating where an object is at any time based on the forces that are applied to it. So, and I have no idea how to do this, so it'll be a whole new start. JS physics engine. How's that? Matter.js. That's cool. Nice. Hey, perfect. So who knows? Maybe I'll just use this. Yeah, yeah. I think this looks pretty good. Let's try it. Try it out. Matter.js. Nice. Start using. Maybe one day I'll build my own. But for now, let's not reinvent the wheel. Oh, let me check comments first, see if anyone left any comments. Nope, no comments. All right, let's go back. Okay, stable release. I don't think this link is working. Oh, okay, tag. Okay, so there are no releases yet. Oh wow, so this is hmm. All right, let's see how old this has been. 2014. Okay, started in 2014, so it's been 9 years. It should be should be pretty stable. And the previous release was just in February. Hmm. Matter.js 0.19. Copy this over. Matter.js. Let's read the README. How we use this. How do we use this library? Okay, so we include it. And it doesn't seem like it has to be a module. Performance with other tools. Examples, tutorials. Let's do tutorials. Build games with Matter.js. Quite a few tutorials here. Getting started. Running and rendering. Minimal example. Built-in render and runner to get you started. Create an engine. Render. 2 boxes and a ground. Methods for creating and manipulating an engine. Gravity. Uniform gravitational field. Yeah, let's take a look at examples. Air friction. Yeah, I'm a little concerned because this seems to be a like everything in one. Yeah. Um, let's see. Let's see what they got. Source, body, collision. Hmm. Let me take a look inside. It's quite a big file. Like it's also using rendering. It's also rendering things. So I'm wondering if it's also doing its own WebGL thing. Webpack stuff. Utility functions that are common to all. Extend, events, and creating events, mouse, constraint, word, composite, guides, getting started, wiki pages, running. Minimal example, built-in render, run. Let's see if there's anything simpler. I mean, this is pretty nice. I can't deny that. Yeah, it's quite nice. P2JS? Physics library. Okay, so Matter.js might not be the most performant. Promising with respect to performance, not written in JS and have poor documentation. WASM, Matter.js, Matter.js, Box 2D, Rapier, P2JS, Physics Engine. Unless you're doing something with thousands of object performance is an area. JS is fast and I've never felt limited by performance. The jam games I made. Rapier. Plank.js, Matter.js, way more stable. These are either ancient or 3D. Ball physics. Hmm. Hmm. So people are leaning towards Matter.js. Let's check out Plank.js. Box 2D physics engine. The documentation. Box 2D is a, yeah. physics engine. So use the library. You need mass, force, torque, JavaScript, plank.js. Doesn't draw anything. Oh, great. So Plank doesn't draw anything, which is what I need because I'm doing the drawing. That's good. Simple example. World object. Create a platform. Static. No collide. And are immovable. Shapes have. Okay, create a dynamic box. Okay, specify mass property. Box shape. Yeah, I'm gonna give this a shot. Plank.js. Take a look at. Okay, so it's still being worked on, which should be good. That's a good thing, right? Let's see. Code. Looks good enough for me. Now then, have they don't have releases. They don't have tags either. I'll just go with the this. Um, they do have a JavaScript file, MJS. 3 months ago, last edited 3 months ago. See what they got. Branches, tags. Yeah, no releases. See master optimization version 2 dev. Yeah, let's just go with this. Download this. Oh wow, this is even bigger. I mean, the jury is out, or the jury is in. I don't know, out or in. We're, yeah. Uh, mm, Past gravity. Let's just give it a shot. I might go back to matter, but before I do, I want to try to see if this will. I'm already going back to matter. Gallery function install. Simply because they show like even the very basic of adding this to the script. And it's smaller actually. So I was surprised. Founders and frameworks. Usage. Getting started. Minimal usage example. Work in both Node and browsers. Running and rendering. Game and rendering loops. Okay. Tutorials. Hmm, Getting started. Webpack. Usage example. Minimal, using the built-in render and render. Hmm. Okay, so I can render my own way. Um, yeah, let's just go ahead and first read up on it. Rendering the bodies in the world as wireframe. Take a look. Include a debug. Render called math.render.create. As a canvas instead of if you wish to create the canvas yourself. Yeah, let's take a look. Matter.render. Hmm. Bounds controller. So it's using canvas, that much I saw. But how is it using canvas? That's what I'm interested in. For example, is it just using canvas by itself? Or is it using WebGL? Hmm. seems to be using just canvas because I see some like strokes and stuff like that. Leads me to believe that it's using canvas. Body position. Okay. Uh, well, let's try it. Hmm. So I'm thinking it will be in game.js. Let's create matter. Hmm. Well, I think I'll pick this up next time. It seems to be quite involved. Um, yeah, let's just call it a day. Thank you all for joining my stream. See y'all next time.